Hello everyone, so today we'll be looking at experiment O3. So let's take a look. Right, so in experiment O3, they say that the aim of the experiment is to actually investigate the effect of the temperature on the speed of reaction. So immediately we must remember that when we are doing this experiment, we must think that we are doing a speed type of experiment, not an energy type of experiment. Okay, even though there's temperature involved. So let's look at the sequence over here. Okay, so we are asked, I'm going to highlight some certain key parts. They are supposed to measure 30 cm cube and using a measuring cylinder. Always look at what apparatus you are using. And then after that, I need to add a 2 cm piece of magnesium ribbon. And then I need to start the timer. And then I need to stir. After that, magnesium completely dissolves. And then I need to record the time taken for the reaction to occur to the nearest second. Right, then they asked me to wash the thermometer and the boiling tube with water and shake dry. So they only asked me to wash thermometer and wash boiling tube. They never asked me to wash measuring cylinder. Okay, then after that, the second one, I measure measuring cylinder again, pour into the boiling tube, alright, and then now I put it in the water bath until it reaches 40 degrees. Okay, and then after that, I measure the time. Okay, so over here, they ask you to repeat this at several temperatures, and they ask you to take calculate rate of reaction over here, and they ask you to do the table that has initial temperature, time taken, and rate of reaction. So your table should have these fields, right? So please make sure you have. Please take note that there are a few things that some common mistake among all of you. Initial temperature needs to be to 1 decimal place because the thermometer can read in between the lines, so it can be like 38.5 degrees Celsius. Okay, time taken in this experiment, they ask for nearest second. So do read the experiment carefully. As a rule of thumb, right, everything that you record should be to 1 decimal place unless it's a burette or unless it asks you to change the accuracy. Lastly, rate of reaction, common mistake still cannot do, a lot of you, that the unit for the rate of reaction is 1 over S. Okay, so please take note, this is the first set of common errors that most of you have. Alright, now the graph drawing, they ask you to plot a suitable graph. Now when you ask to calculate rate of reaction, the axis over here needs to be the rate of reaction. Okay, and then slash 1 over S. Right, so this one needs to be correct. It cannot be time. Right, if they ask you to calculate a reaction, please use rate of reaction. Okay, moving on because there are more important stuff. Right, now suggest a reason why there's a need to wait for a minute before measuring the initial temperature of the reaction. So this one is actually quite unique to this experiment. So the reason why you need to wait for 1 minute, right, it's not because like you're measuring the temperature of the water bath or whatever. You are actually just waiting for the temperature throughout the liquid to be the same, right? So we are trying to ensure temperature throughout entire liquid is equal, okay, or the same. We're just making sure that the whole liquid is the same temperature. Okay, so that's why you need to let it wait for a while. Right, now this is the question that has the most problem. Okay, rubbing the surface of the magnesium ribbon before the reaction will lead to more reliable results. It's good that all of you remembered that rubbing the surface of the magnesium ribbon actually removes the MgO, the magnesium oxide, and it will give you, please take this down, it will give you more accurate result. Okay, take note of this. It will give you more accurate result. However, this question is asking you whether you get more reliable results. So we need to think what is the difference between accuracy as well as reliability. So accuracy is actually closer. What we mean by closer to true value. Is it closer to the correct answer? Reliability is whether if I repeat, every time I repeat, is it repeatable? Can I keep getting the same results all the time, right? That means if after I rub this one, then I run, if I do the exact same temperature, will I get the exact same results? All right, so this answer actually you can both agree and disagree. Okay, so generally I would say I'll disagree. The reason why it is not reliable, so imagine, right, you have this magnesium ribbon. The first round you rub, make sure that you rub off everything, right, and then you throw it in. Oh, then very good, it reacts with the magnesium and not the magnesium oxide. The second time you rub, but you didn't rub as well, and then the third time you rub, you maybe rub different. So every time, what we are doing here is that we are introducing another variable, and therefore it makes it less reliable or less repeatable. Less times that you can repeat and get the exact same results. So I would say that no, it doesn't become more reliable, right? It's because since, right, different amounts of MgO will be rubbed off each experiment, experiments become less reliable. Now, we can argue the other way, right? We can say that yes, it becomes more reliable because originally we cannot say how much MgO there is on top of the Mg, right? But if I make sure that I rub off every MgO possible, will it become more reliable? Yes, it will become more reliable. So you can argue it both ways, but what is more important in this question for this practice that I wanted you all to learn is what's the difference between what we say more accurate as compared to more reliable. So this is the main learning point for you for this one. Okay? All right. Now let's look at the last one that I want to talk about. Sources of error. Now, so this is an experiment that you are measuring time. Okay? You're not measuring temperature, you're measuring time. So over here, the temperature part is not a very good source of error, right? Because you have actually some control over the temperature. You can measure the exact starting temperature, and whether there's heat loss in the environment, it doesn't matter. The thing is that we write down here, your dependent variable is actually time. So therefore, or slash rate lah. Therefore, you need to think of what will affect the time and the rate. And in this experiment, the independent variable is actually temperature. So anything got to do with the temperature is you are changing along the way. So temperature is out of the question. So what else will affect the rate of reaction? We have concentration, right? We have a particle size. These are pressure, right, and catalyst. So these are the two things that we should be focusing on: concentration as well as particle size, right? Now, take note, there are certain things that you use most of the time, right? So let's take a look at some. Let me show you. Firstly, is whenever they ask you to wash and shake dry. You must think this is a possible but not all the time. So possibly by washing with water and shaking dry, the boiling tube might have excess water. And if we add in our 30 cm³ of hydrochloric acid, and if there's water inside, the concentration will drop, rate of reaction will drop. So that is a possible source of error, okay, because it affects the rate of reaction. This experiment, we only want temperature to affect the rate of reaction. We cannot let any other things affect. Right, so now I need to teach you how to write the error properly. So we said that washing and shaking dry boiling tube might cause, right, concentration of acid to decrease, resulting in lower than expected rate of reaction. So the error must say a few things. So what is the thing that we do that is the problem? What is it going to affect? And what effect does it have on the results? Okay, so these three things. So the improvement here is just to replace the boiling tube all the time. Okay, use a new boiling tube all the time. Now, the second one, which is a possible one, but not something that is very significant, is that we are always using 30 cm3 of hydrochloric acid, but we are using a measuring cylinder. And you know the amount of acid that we add in every time might be different. However, why I say that this is not so significant, right, is because rate of reaction is affected by concentration, and regardless of how much acid I add, the concentration is always the same. Okay, however, this is still a possible source of error. Okay, it's still a possible source of error. So let's write it down. So another possible source of error is that using measuring cylinder to measure acid is not the most, and I want you to learn this word, precise instrument. Right? So therefore, volume of acid in each experiment might be different. So then the way to improve this is that we use a burette, right, every single time. Okay, so what other sorts of errors can we look over here? I wouldn't say the part about excessive heat loss to the environment, because that's what we are changing. The other one would be definitely, of course, we can't say the magnesium ribbon because that is repeated over here. So we cannot repeat the magnesium ribbon, but we can sort of say that the size of the magnesium ribbon, because now we are just basing on length. So what might be better is to actually base it on mass of the magnesium ribbon. So every experiment measure equal mass of magnesium ribbon. So that might be actually better, okay, to make sure that you have the same mass of magnesium ribbon every experiment. Right, so these are the common mistakes. However, if you have another mistake that you're not sure how you can improve that, please do let me know. All right, okay, all the best.